We started our casting project by designing a 3 by 6 inches pattern in SketchUp. It was made out of PLA and had a 70% infill. It was converted to an STL file and uploaded to Cura. On Cura, we scaled and printed the part and then uploaded that STL file to a TAS 3D printer. It took 6 hours to print the final part. The dimensions of the mold were 8 by 12 inches, created out of 1 by 1 inches wood. Safety was our top priority, of course. During the process, we had an experienced individual supervising the entire project. A controlled environment with minimum risk was used as the project site. The person operating the furnace and pouring the molten aluminum wore fire-resistant clothing and gloves along with safety goggles. "10 pounds of casting sand was purchased through Amazon. Initially, the sand was added, and then the 3D printed pattern was placed into the sand to create the negative. However, we did not have enough sand to cover the pattern in a leveled fashion, so we flipped the pattern over and placed the molding frame around it. Baby powder was then used to cover the pattern, and the casting sand was added. The entire apparatus was then flipped over, and we attempted to remove the pattern. However, casting sand was stuck within because we did not use enough baby powder originally. The 3D printed part was placed within the drag. Much more baby powder than the second attempt was then used to coat the part so it wouldn't stick during the mold removal process. Finely ground sand was then sifted and spread on top to make a layer to additionally help prevent sticking. Sand was then packed down into the bottom portion of the mold. We made sure to level and flatten the sand. We then added the sprue and the riser into the coat, checking to make sure they were both correctly lined up before the holes were made. The furnace was then turned on for preheating. Once the temperature reached 1350 degrees Fahrenheit, we put in the aluminum rod and allowed it to melt. After the aluminum had fully melted, the dross was removed. Using tongs, the graphite crucible was lifted and turned to pour the molten aluminum into the sprue. We realized after it was fully poured that the sprue and the riser had not fully filled. All remaining aluminum was heated and melted down and then poured into the mold. Once all aluminum was fully poured, we then had to wait approximately 20 minutes for it to cool. As expected, the aluminum shrank throughout the cooling process. A metal tool was used to pry the part from the sand. Using tongs, we lifted the part and held it under a running faucet to fully cool it for handling. A bandsaw and a cutting wheel were used to remove all excess metal to ensure the back of the part was flat. Then we used a portable grinder to fully smooth the part. Finally, a Dremel and a file were used to eliminate any additional sharp edges. A smaller part should have been made for the size of the furnace. More casting sand would have improved the process. Because we did not have enough aluminum originally, the first batch began to solidify by the time we poured in the second batch of it. This led to product impurities. This process exemplified the idea that sandcasting is not ideal for large production volumes or high-quality surface finishes.